Okay, let's get going this morning. I'm going to start a new topic on today, excuse me. It's 5:29. This is video 109, and we're talking about the division of polynomials. So I'm going to talk just a little bit before I do these first two problems, and then move on to what they really want you to be doing. So let's see what we've done so far. We've subtracted polynomials. We added polynomials, so we'll say addition. We multiplied certainly polynomials. And of course we just finished, and we'll continue doing so, we factored, and we use the GCF factorization. We'll talk more about that later. So that's what we've done so far, and that's what's going to be on your test. And now, well, what are we missing? There's subtraction, addition, multiplication. We're factoring because it's so tied to multiplication. That's why I snuck it in there, only with a monomial, only with the GCF. And now, obviously, what we're missing is division. So let's talk about that for a couple of minutes. And this is some examples that we're going to do. You can divide any polynomial by any other polynomial. And we're only going to do monomials and binomials, but you can do trinomials, any kind of polynomial, and we're going to set up some rules here, and I'm going to put the rules over here on the side when we do division. Number one, no fractions of any kind. We're going to agree, just as a game like Monopoly, think of Monopoly, right? You can't roll a 13. If you go to, if it says go to jail, you have to go to jail, etc., etc. And we're going to say no fractions. So that's going to call that a restriction. Okay? So for example, in this, notice that 2 divides 4, 8, 12, and x squared is going to divide all of these guys. And the same thing with the other one. So we're going to rule out fractional coefficients and anything that would turn into a fraction with the variable on the bottom. Now we said that before. For example, we said that 1 over x squared is not a polynomial because we won't allow polynomials to be defined when the variable is on the bottom, in the denominator, okay? So we'll keep that in mind. And these are kind of artificial rules because, like I said so many times, polynomials are just, and their cousins, the algebraic expressions, are only representing numbers, kind of numbers that we have. So we're also going to rule out one more thing, and that's a remainder. So what do I mean by remainder? I'll get over here and make sure that you can look at this carefully. Say I divide 8 into 19. Well, let's see, 8 goes 2 times. 2 times 8 is 16. And there's the remainder, 3. So we would write that the correct answer is 2, remainder 3. We're going to rule that out in the math, even though you can get that when you do these math problems. So remember, when I start playing this game, and we'll play it for a couple days, I'll give you practice doing it. Traditionally, kids need extra practice to do this. I'm only doing the last operation for polynomials, trying to finish up the chapter. We have to factor by binomials as well. We'll get to that, big deal in Regents math. And we're agreeing that no fractions of any kind, no rational numbers, that is, no coefficients with fractions, and the variable can never be on the bottom. And you'll see that turns out to be the same thing as saying no remainders, even though they've existed in polynomial math as well as they exist in this simple little example over here. So the remainder will always be 0 when we do our math. And if the remainder is not 0, then we'll say something's wrong with the problem. That's the way we'll play this game. So I hope I made all that clear. And I can always repeat myself, and I'm going to erase this stuff on the bottom here, and I'm going to do these two problems and then go to the real focus of this lesson, I'm going to, because the first two problems, I'm doing the easy stuff that you probably don't even need me to teach you, where I'm dividing by a monomial, but you'll definitely need me to teach you when you divide by a binomial, and again, no remainders, no fractions are going to be allowed, okay? Just the rules of the game, nothing that serious. So I put our attention back here, and I'm going to work on this. And question number 1 says, divide this trinomial to the 4th degree by 2x squared. So we just go back to elementary school again. After all, polynomials are just representing numbers. That's all that's going on. No big deal. And of course, you have to remember the quotient rule, but it's been my experience that kids don't really have a tough time with the quotient rule when we do it this way. Okay? So this becomes this. And then most high school kids aren't really challenged that much by this. I can do it in my mind. I won't do it when I'm actually doing problems. But I'll do it here, okay, just for the first time, so you can see what's going on, okay? And what I'm really doing here is I'm just dividing each one. I'm breaking it up into pieces and dividing each one. And actually the plus is no good. In my mind, I'm dividing each one by 2x squared. So maybe I break it up into pieces in my mind. There we go. That's a better representation of what's going on. So I'll draw a little implication arrow here below. And now 2 goes into 4 2 times. X to the 4th, x to the 2nd. 4 minus 2 is x squared. And now I do the second one, but a negative divided by a positive is a negative. So that becomes 4, and then 3 minus 2 is 1. You see why you studied in 8th grade the quotient rule. It becomes very important in high school. And finally, 2 into negative 12 is negative 6, and x squared and x squared cancel. 2 minus 2 is 0, x to the 0 is 1, and there's the correct answer. Okay? So this is a quadratic trinomial. Notice you can factor this. So it wouldn't be simplified until you wrote that. But this is what we got when we divided, and then we factored it and we simplified it. So you'd be expected to do that in high school. Okay? And this would be considered the easy stuff. They really don't spend a lot of time on it in the books. Okay? And now I'll do the second one. And I'll certainly give you work on it. Okay, so here we go. We'll just quickly clean the board here so we can do the second one. And I want to finish the video with doing what is quite a bit more challenging for most 8th graders, especially in the beginning. Okay, but once you get used to it, it's not bad at all. Notice 3 goes into 12, 6, and 9. So again, this time I'll do the mental math part because I'll draw the implication arrows, not the implication arrows, just an arrow to indicate my thought. And there we go. And what I'm really doing is this, this, and this. Okay? So you got to be able to handle that. 3 goes into 9 3 times, and 5 minus 2 is 3. 3 goes into negative 12 4 times, and 4 minus 2 is 2. And finally, 3 goes into negative 6 2 times, and 3 minus 2 is x. And notice we can factor this one. Although 2, 4, and 3 are co-prime numbers, they share the x. Get used to this. You'll be doing a lot of this in math. And there it is simplified. Okay? So I divided it, and then I factored it. So I'll give you some problems to do this. Later today, I'll be doing the assignment. I got to give you at least the morning to do the assignment there. And now, with 9 minutes out, I'm going to do one or maybe two where I'm actually dividing by a binomial. So let me write it out. Maybe I'll only do one. We'll see how the math works out this morning. I can always do a follow-up. I will do a follow-up video. Okay, get this out. Okay. And now, let's just do a real easy one. Let's divide 3x squared minus 4x minus 4. Now notice what I'm doing here. It's very important to keep an eye on this. By 3x plus 2. So this is something that high school kids often haven't seen. And so I'm going to do this, and I'm going to use long division. And before I do it, I want to do a problem. I'll do two problems the old-fashioned way, and then I'll do this, and then we can follow up on everything here. Let's say I wanted to divide 8 into 912, and I know I'm going to have a remainder of 0. So 8 goes into 9 one time, so multiply 8 times 1, bring down the 1, 8 goes into 11 one time, 1 times 8, okay, and bring down 1 times 8, okay, bring down the 8, so we got 1 here, and 1 times 8, let's see, 1 times 8, and so 8 goes into that, and then the 8's under here. Sorry, I saw the dot here and I got confused. I don't want to do the video over for that reason, especially in elementary school math. And 8 goes into 32 4 times. 4 times 8 is 32, and that's how we were taught originally in elementary school. Okay, and again, 8 goes into 9, 12, 114 times. And just notice what I'm doing here from elementary school. I'll be doing the same thing with polynomials. Okay, so keep an eye on that. I'm going to do that. I'm going to do another problem from elementary school, and I'm going to divide 12 into 168, and I'm going to get a remainder of 0 as well. So if I don't get a remainder of 0 in the new game that we're playing, then we say the problem's invalid. It's not a polynomial. It's something else that can be defined. It means something, but it's not something that we're doing now. It's not something that the Regents is interested in. Let's just put it that way. So 12 doesn't go into 1, but 12 goes into 16 one time. And again, I'm showing you what you were doing. And then 12 goes into 48 4 times. And there's your remainder of 0. Now we're going to be doing this in a couple seconds now. So keep a close idea that this is what I'm doing. I'm only doing elementary school math, but I'm adding to the math in the sense that now the polynomials represent numbers. Okay? The polynomials, the algebraic expressions that we've been doing represent numbers. I'm sorry about getting stuck here. There was a dot here and it confused me. And all of you, since you made it out of 5th grade, know what I'm doing. And I did this for a reason, because now for the first time I'm going to divide this by this. So let's write it out elementary school fashion. Notice that some kids confuse the division sign with the radical sign. That's very silly. You don't want to do that. Okay, guys? This is just dividing, just like I divided 8 into, what number did I divide 8 into? 114. So you can just sort of keep it on the side here and see what's going on. But notice it's a binomial. So the methods that I'm using have to be a little different. So I'm going to do this one slow. You can play it back. I'll certainly follow up on what we were doing here. And here we go. I start with the first term, the highest term, and 3x goes into 3x squared. x times. Now, a lot of kids, they raise their eyebrows and they say, well, how'd you do that? Well, I'm just doing what I did over here. 1 times 8 is 8, and there we go. So here I do the same thing. X times 3x is 3x squared. And then I'm going to subtract that and get 0, because that must happen. And now where kids really get confused sometimes is I'm going on to the second term here. Well, x times 2 is 2x positive. Everybody see what I just did here? So I multiplied this times this and got this. Why did I choose the x? Because it matches the 3x squared, and I'm planning to subtract. But remember that subtraction in polynomial math is taking the opposite. So I multiplied this times this and got this, lined up the x's, and now I subtract. So this becomes negative, and this becomes negative. And you have to remember in this math that subtraction is taking the opposite. Okay? So there's the 0 that I desired so much. There's the 3 here. And this, what number was this? 912. I had the wrong number here. Okay, so here we go again. And there's the 8, and there's the 1, and there's the 11. So 8 goes into 11. That's all I'm doing here. And this went away. And now I go over here, and this went away, and I add this up, and I get this. Now I'm going to divide 3x into negative 6x, just like I'm going 8 into 11. You should look at that. Kids get confused here. And obviously you have to work out some problems on your own. And so 3x goes into negative 6x negative 2 times. So let's see what happens here. Negative 2, and then I bring down the negative 4 over here. So let's multiply it back. So we have negative 2 times negative positive 3x is negative 6x. And then negative 2 times negative positive 2 is negative 4. So when I take the opposites there, I get 0. Everything goes away. So the remainder here is 0. So let's go over what we did one more time. It's always been a bit of a problem to do. 3x goes into 3x squared, x times. Check it. X times 3x is 3x squared. Subtract. Go to the next term. X times 2, because then I'll take care of these other ones next. X times 2 is 2x. Take the opposite. This has to cancel. If it doesn't, there's no math problem. Okay? And now I go to the next term over here. When I add negative 4x and negative 2x together, I get negative 6x. So I match again. What number matches negative 6x? Negative 2 times 3x. Negative 2 times 3x is negative 6x. Negative 2 times positive 2 is negative 4. You see, I matched these, and when I took the opposite, I got 0. Now, I'm way over the limit here. I'm going to check this, and we'll come follow up with a video a little later, and we'll do some more of these. And let me just move this over here. Hopefully the video doesn't revolt on me. And now, what's going to happen, I'm going to check this. Because after all, if I found, and by the way, this goes one time, because we were working before, okay? And then there's the 8, and then there's the 3, and you bring down that. So what's the check? Well, 114 times 8 equals 912. What's the check over here? This times this equals that. This times this equals the underneath. And this times it by the dividend, if you like. And this times this, using FOIL, should equal what I have under the, and then we got this, and then we got the 2x, and then we got the negative 4. I put together my like terms, and yes, I got everything here. And then I get 3x squared minus 4x minus 4. And there's the check here and there. So later this morning, I'll follow these up a little over. Hopefully,